Assalamualaikum and hello everyone. Welcome to our 160 group presentation. Today, we will share our mini project for BITS 2343 computer networks. We are group 160 and our team members have worked together to design and implement a structured network setup. And this is the members of our group.
Here's are the team members. We have Nurin Akila binti Hamdan, Nur Adani binti Bakri, Iman Aisyah binti Azrul Hisham, Nurin Amani binti Yazid, Adriana binti Muhammad, and Sharifah Nur Ain.
Overview of the University Network Design and VLAN segmentation at HQ. This network is structured with a central headquarters or HQ and multiple branch locations such as branch 1 and branch 2. The HQ network is segmented into multiple visual local area networks or VLANs identified as blue, red, and orange. These VLANs are designed to isolate and manage traffic for different groups of devices, ensuring efficient communication and enhanced network performance. Routing protocol and traffic management to ensure seamless communication between the HQ and branch location. The network employs the Enhanced Entire Gateway Routing Protocol or EIGRP. Additionally, access control lists or ACLs are likely implemented to enforce specific communication rules, providing security and control over traffic flow between network segments. Server infrastructure. The network incorporates several servers to deliver essential services to the university. First, a web server in the Orange network hosts the university website identified as .utem.edu.my. Second, a DNS server translates domain names into IP address for easy access to network resource. Third, a mail server is in place to handle email service for the university community. These servers are crucial for the university's day-to-day operations and online presence. Dynamic and static IP configuration. To simplify network management, most devices are assigned IP address dynamically using DHCP servers. However, devices in the Orange network are likely configured with static IPs to ensure stability and better control. Role of the DHCP relay agent. The HQ router functions as a DHCP relay agent facilitating dynamic IP address assignment across the network. This setup ensures efficient and streamlined management of the network's device. This network topology ensures efficient traffic flow, scalability, and secure communication. It supports the university operational and educational needs while providing a strong foundation for future growth. I hope this has given you a clear understanding of the architecture and its key features. Now we go to the next slide.
Objective of this project is it has 8, which is the requirement to achieve the result for this project. First requirement is to allocation the IP address for HQ for branch 1 and branch 2. Second requirement is to configure the VLAN, which is to assign VLAN blue, red, and orange. Third requirement is VLAN port assignment. And fourth requirement is inter-VLAN for routing. Fifth requirement is routing and access control, which is SDL. Sixth requirement is DHCP server configuration for purple server, red server, blue server, and orange server. Seventh requirement is to web, DNS, and mail server to configure essential for web, DNS, and mail server. And eighth requirement is to customize our homepage group, which is group 160.
This slide represents our physical network diagram. It visually maps out how different device and network components are connected. Color-coded section represent a different VLAN. For example, purple network, green network, and orange network, and also blue network and red network. For router and switch act as a backbone, linking multiple VLANs for efficient communication. The IP addresses are assigned to different network segments and optimizing traffic flow and security. So next, we move to the next slide, which is we have a logical diagram design. And as you can see, the logical diagram consists multiple interconnected entities. And this represents a structural flow and data and how different components interact. So next, I will explain about IP address allocation strategy for our network. In this step, it is crucial to ensure efficient communication and network organization between our HQ and branch network. So our network consists of two main segments, which is HQ network and branch network. Each of these segments has been assigned a specific IP range to accommodate the required number of devices. For HQ network, use the 192.168.160 and 64/26 subnet. The provider's 62 usable IP address and sufficient for our HQ device. And branches network use 172.160.00/16 subnet. This is further divided into two subnet, which is for purple network and green network. For purple network, which requires 16,000 address, and for the green network, which require 4,000 address. For additional, we configure an ISP loopback, which is loopback 160 interface for network testing and external connectivity. As you can see in the diagram for network, for HQ network, we assign a specific IPs to the HQ router, web server, and the HCP server. This structured approach ensures smooth network operation and prevent IP conflicts. Next, VLAN assigned in our network. We have divided our network into different VLANs, and each VLAN has a specific purpose and IP address range. For trunk, the port is GI02 and used for connecting switch at 192.168.99.0, and the VLAN 11 we name it as red at port FA03 until FA010, and assign IP range from 192.168.160 and 64. For VLAN 22, we name it as orange at port FA011 until FA013, and use IP address 192.168.160 and 18. For VLAN 33, we name it as blue at port FA01 until FA02 and use 192.168.160 and 88. For VLAN 99, we name it as management and use for network management at 192.168.99.0. So next, we move to the branch network, which is we have purple network and green network. For purple network, the network address is 172.160.0.0 and usable host range is 172.160.0.1 until 172.160.63.254, and the broadcast address is 172.160.63.255. For green network, the network address is 172.160.64 and 0. The usable host range start from 172.160.64 and 1 until 172.160.79.254. The broadcast address is 172.160.79.255. This IP scheme allows each branch network to accommodate its required number of devices without running out of addresses.
In requirement 2, we need to create VLAN in HQ and assign according to their host group, which is we have blue, red, orange, and management here. After configuring with IP address, we can proceed to VLAN in switch. For this case, we are using switch 1 or S1 to configure. Use VLAN with VLAN ID next to it in global configuration mode to add VLAN in switch 1. Since we have 4 VLAN, blue, red, orange, and management, we need to do one by one. First, VLAN 11, and then name red, and then VLAN 22, name orange, and then VLAN 33, name blue, and lastly, VLAN 99, name management. After creating VLAN, we can check using command show VLAN brief. These are the result from our switch. Moving on to requirement 3, after creating VLAN, we need to assign each computer to appropriate broadcast network, configure trunk port to connect switch and HQ, configure access port, and assign switch port. Let's go through step by step. First, click on switch and enter global configuration mode, and then enter specific port with command INT follow with port name. Next, switch port mode access and switch port VLAN 11 and exit. This process should be repeated for other as well. Next, to configure trunk, enter INT with specific port and then switch port mode trunk. Switch port trunk allow 11223399 and exit. Now, to configure access port to ensure they belong to the correct VLAN, enter INT with specific port name, switch port mode access VLAN 11 and exit. This must be repeated to other as well. To verify all these are correct and has been done, we can check by using command show interface trunk.
Requirement 4, Inter-VLAN routing. Configure HQ router for inter-VLAN routing. At router HQ, define sub-interfaces and the respective IP addresses. Use the encapsulation.1q VLAN number command to define the VLAN for each sub-interface where VLAN number corresponds to the VLAN ID. At router HQ, there are 3 VLAN networks which are red VLAN, blue VLAN, and orange VLAN network. For red VLAN, the configured VLAN ID is 11, while for the blue and orange are 33 and 22. There are 4 sub-interfaces, which is the Giga Ethernet 0/1.11 with IP address 192.168.160.95 for the red VLAN network, Giga Ethernet 0/1.22 with IP address 192.168.160.81 for orange VLAN, Giga Ethernet 0/1.33 with IP address 192.1.168.160.89 for the blue VLAN, and lastly, for the native truck, Giga Ethernet 0/1.99 with IP address 192.168.99.1 All of the interface has been encapsulated with the respected VLAN ID according to the VLAN network.
As for requirement 5, we have to use EIGRP as router protocol. By using router EIGRP1, and we have to configure this at all routers for the branches and the HQ. So we have to add the network addresses and with respective to its wildcard mask. 80.0 is for router, the network address between router HQ and branch 1. 80.4 is the network address between router HQ and branch 2. 160.80 is for orange network, 160.88 is for blue network, 180.64 is for red network, 180.64 and 0.0 is for green branch, 160.0.0 is for the purple branch. Next, so this is the ICL configuration for branch 1, where the branches network is supposedly can communicate with each other and only with the orange network. And red and blue network can only communicate within their VLANs and to web server orange network. So firstly for branch 1, it is for the access list, it's all based on whether we want to permit the purple network. Since the branch 1 is for purple near purple branch, so we're going to permit purple with which network and deny purple with which network. So for example, permit IP network for purple network to access 160.80 is for orange, and then second of the list is permit purple to access the green the green branch, and then for permit UDP of the purple for host 172.160.0.2. EQ domain is specifically just to allow DNS services so that it won't get blocked for DNS. And let's go for deny IP. For deny IP, we want to deny purple from accessing 160.88 from accessing blue, and deny purple from the network 160.64 is for red. And lastly, we have to put on list of the 7 of the list, permit IP any to avoid any errors of the logic of ACL, and the permit TCP any EQWW is basically just to allow the network, allow the website services to still functioning well. Means every hosts in every network supposedly can still access the web server. And next for branch 2 is just similar, is that the configuration is basically permit the network for green branch to which network and deny the network address for green branch from which network. Since branch 2 is for branch 2 is near the green branch, so it's just the similar as explanation from just now. And specifically for permit UDP again, permit UDP for the green network, the green branch, specifically to host, and this 170.160.0.2 is actually host from the purple server host from the purple branch. It is specifically just to allow DNS services again. After we have create the access list, we have to apply it on the interface. So for branch 1, in this case, I would like to apply for branch 1 at serial 0/0/0. I want to apply the using the command access group to apply the access list of extended branch 1 underscore VLAN33 out of the interface of S0/0/0. And also it goes the same for branch 2. For branch 2, which is near the green branch, I also apply access group for branch 2 underscore VLAN33 out. The result shown that for green branch host, which is G1, the G1 host is unable to ping with any host from red and blue network. And same goes for the purple branch host. We use P1. So P1 is unable to ping any host from red and blue network. Next, any host from purple branch and green branch, supposedly they can ping each other.
Next is requirement 6. Requirement 6 is the configuration of the HCP server. First, it will assign IP address dynamically in all hosts except in orange network. The HCP server is assigned based on their own server. For example, red VLAN, it will use red server, while blue VLAN will use blue server. While for branches, green and purple will use purple server to dynamically assign the IP address. So in the green server, it should in the router at green server, it should has a IP helper address to help it get the IP address dynamically from purple server.
Requirement 7. Web, DNS and mail server. Configure essential servers. Set up a web server and a DNS server with appropriate settings. Choose one server to act as the mail server and create accounts for all group members. The web server in Orange Network has been chosen as the mail server. All of the 6 group members' name has been created in the user setup with their own username and password. The user account has been chosen to test the connectivity from different PC. Both sender and recipient, which are Adani and Adriana, are able to send and receive mail from each other. For the DNS connection, a server purple network has been configured with DNS service. The IP address 192.168.160.82 has been set as the web server address and named as www.g160.utem.edu.my. Once user browse the web page from any host either in HQ or branches network, it will display the web page containing all the group members' profile.
As we can tell already, HTTP allows us to host a basic web server and serve web page to client on the network. Now, I will demonstrate how to configure and access to HTTP service in Cisco. First, open any server and go to the service tab. Click on HTTP and make sure the toggle is on to ensure the default web page is available. On this HTML section, you can edit page content according to your needs. For example, we want to host a page that can display all group members. Here are the code. On the first 4 lines, this will be the header and it will display a message group 160 that has been set to font size 20, bold and in red color. Then we use HR to separate line to display course code BITS2343 and lecturer name. Second part here is how we design the background and picture. For body, text has been set to Arial and center with background color code. For layout member card, we use flags to align horizontal and add 20 px spacing between members. For styling card, we set 200 px for width along with a round corner and hair shadow effect. For the card background color is white. For each profile, the width is set to 100% which ensure all the picture will be fit inside the card. And for hover effect, we set the scale 1.1. To display each member's picture, we need to save in computer and remember the file path, and we need to enter exactly file name in here. Then we can add other information such as full name and matrix member below it. This template can be used multiple times. And lastly, we need to close the code using HTML element again. Make sure to save before return to File Manager. And on this section, we can delete unnecessary file that has set for default web page. Don't forget to upload same file picture that used in HTML code because it won't display picture on the web page if no reference in it.
To conclude, this mini project successfully demonstrates the design, setup, and configuration of a network simulation that meet all the defined requirements. Our group ensured that the network provided excellent connectivity, robust security, and efficient performance, which are essential for a business environment. Achievement in network design, one of the major highlights was the implementation of VLANs for both the HQ and branch networks. This improved network segmentation, reduced unnecessary traffic, and enhanced overall efficiency. EIGRP routing was configured to enable fast and reliable communication between the branch, ensuring optimal data exchange. Additionally, access control list (ACLs) were applied to enforce strict security rules. This will allow only authorized traffic, ensuring that branch hosts could communicate securely with one another and specific networks, such as the Orange network in HQ or the web server. Real-world relevance. This project gave us practical experience in configuring key networking components like IP addresses, VLANs, inter-VLAN routing, and ACLs. The knowledge and skill we have gained through this experience will be highly valuable for tackling real-world networking challenges in the future. In summary, this project not only meets its objective, but also provide a solid foundation in understanding and applying advanced networking concepts. That's all for today. Thank you for your attention.